having a professor panel, so there'll be free pizza for whoever wants to come. And the people on the panel are Joe Zachary, David Johnson, Koos Vandermeer, and Mary Hall. So it's a pretty unique opportunity where I'll have just a panel of professors where you can ask them pretty much within reason whatever you want to ask them about. It's pretty cool. Professors, when you actually talk to them and figure out their stories and their backgrounds, they're really cool people to talk to. So hopefully you guys will take advantage of this opportunity and come and also get free pizza or dinner or whatever. So yeah.
I noticed they put the headliners in order of importance here: pizza and props. And also, Web 1230 is up the stairs, right? Like it's not on this section of levels; it's the cafe level. So 4:30. Leave some pizza for me. Okay, let's do a few little announcement things, and then we'll maybe talk about the assignment, and then some new material. So, we have a paper test next week. Woo! Not exactly going to open up the space here too much, but it'll make it a little less crowded, and we'll have it memorized, but I think are important. Yeah.
Will we have that available to us prior?
I'll try to send it out like that Monday or something like that, so you can see what's on it. No electronics, nothing covering your eyes, so all your hat and brim people got to turn it around. And bring your student ID, you should show that when you turn in your test. Okay? Pretty basic thing. Typically, I don't think these tests are too bad. I try to make them not too long. I know some of you are very fast at this stuff, and some of you are a little slower. And we're not really trying to see how fast you can pump out the information. We're trying to see how well you can do it. So don't be surprised if there are some people that are leaving after 20 minutes, 25 minutes, having finished the test. Don't feel bad about it. If for whatever reason, they're just fast test takers. Take your time, don't stress out about it. But it's not designed to make you write at hyperspeed the whole 50 minutes kind of thing, right? Some of you will take the full time, obviously, and that's okay.
Will we all have like scratch paper on the test being able to like run through the code before we actually use that on paper?
There's probably going to be a blank sheet on the back you can use for that purpose. This question was on scratch paper. I can't handle just having tons of sheets of paper all over your desk. It's too hard to monitor.
Is the majority of the code looking at a piece of code already written and determining what it does, or writing our own code?
Yeah, so there's going to be a lot of tell me what this evaluates to, tell me what this code does, how many times it's iterate kind of questions. And then, of course, there'll probably be a few little methods to write. And, we'll kind of creep up in complexity as we go. Expect maybe a small class to write or something like that at the very end. But a lot of it will be more evaluation than generation. But we need to test both sides a little bit. Now, to prepare for this, Monday we'll do like a review lecture. Probably just have a giant Kahoot quiz and see how you do. The lab on Tuesday will probably be something closer in form to the test, but of course not as long or covering all the same, all the topics. But so something, probably go over like 2 questions, have you do them, and then talk about them, and then go over 2 more questions and talk about them, that kind of thing. So it'll give you a chance to exercise your skills. I'm going to have some kind of online Canvas quiz thing that has some questions. The problem is Canvas, the way it wants mostly to do multiple choice kind of answers, gives a little distorted view of what the test is like. But I can do some of those, evaluate this chunk of code and tell me what comes out, A, B, C, one of these 4 answers kind of things. But don't think that's exactly what the test is going to be like. The lab will be a better measure of that. And then some of the help hours will be turned into group review. I'm not trying to set up something where we have like 1 review session and all of a sudden 150 people descend on the CADE lab or on one whiteboard or something like that. So we're just going to turn a fair amount of our help hours into hopefully groups of 5 or 6 that want to stop by and go over some questions and do things like that. There's not going to be an assignment coming out this week, so the idea is that you should be able to have some time to study. This online quiz will probably be like a participation kind of deal or something like that. So you should do it. It's not worth hardly anything, but it's there for your benefit.
Will the lab practice test be like a grade or?
It'll be like a lab grade. Yeah. So if you're there and do it, you'll be good. So anyway, well, more chance to talk about this a little bit on Monday, but hopefully we'll talk about topics more on Monday, basically. But there's going to be hopefully plenty of ways to kind of check your understanding of this material, these different forms, and get you ready for the test. And again, I used to write kind of more complicated tests, and then I've sort of realized over time that I can write what to me are like the most obvious questions, and still a bunch of you are going to be stumped, so there's no point in getting too tricky here. So I try to make it pretty straightforward. And the review lecture one, I try to pour all my creative evil energies into trick questions on that one, so I get it out of the way, and then scare you a little bit maybe, but it should be pretty straightforward on the questions for the other one. Okay, any other questions on that before we move on? All right, let's talk about the assignment for a second. So, what's going on? Any questions there? I feel like look at the discussion, there's been a fair number of clarification kind of questions on the discussion. Some of you are starting to creep in a little bit. My code doesn't work on the discussion, and just email the help email for that. No one wants to, well, other people might be enjoying your suffering, but it doesn't really illuminate the assignment very much to just see that kind of stuff. So if it's something that's clarification oriented, Java oriented, discussion's a good forum for that. If it's something about your code, which you can't share on the forum anyway, then emailing us is better, where you can actually share your code, and I can look at it more specifically. But I'm sure I did not answer everyone's questions last night, so anything? Okay.
Does the phrase completer need to return the first match of the key, or just a match of the key and the one below that?
So the question is a phrase completer, and again, you type in some start characters, maybe not even a boy, but just a bow. And in the array of phrases, there's a whole bunch of things that might match that: a book, a boy, a box, all those kind of things. And as long as the binary search doesn't distinguish, when there's multiple options that are equal to what we want, binary search doesn't have a specific one it looks for, right? It's just as soon as the midpoint hits a box, and let's see, X, Y, a boy would go down below it. Sorted, boring. So those would all be matches, right? Binary search is just like, is it here, is it here, is it here, is it here, here? Finally says, is it here? It says yes. It doesn't do any additional work to try to get to the first one that matches or anything like that. But then your job is to give in this index, that start index. And if that's not -1, there's at least one match, right? To somehow go and crawl around and see how many other matches are in the neighborhood here. And again, you can kind of, if there's 20 matches, as long as you come up with num matches of them, I don't care which ones you pick. If there's only 3 of them and the num matches is like 7, you better pick all 3 of them. But that's really all about it, right? So there's the binary search part doesn't always find the first one, just some random one in the middle of that phrase set. So that makes the collecting the rest of them a little bit harder, right? Because you can't say, but you can turn this information into, like, go find the first one or go find the last one. You can find those things out, right? And you should be doing that in your collect and matches code. Yeah.
When we're searching, the example you gave us, David did 11. You use the first word, but it seems like you talk about the first letter.
It's characters, just plain characters.
So the single first character is all we're looking for, not the first token of the word?
Or if I type in this, there is 1, 2, 3, 4 characters, and I'm trying to match those 4 characters against the first 4 characters of these phrases. Nothing to do with words, nothing to do with spaces, nothing to do with one character. However long this is in characters, I'm matching it with, so I'm looking here, I'm looking here, and I'm looking here to match. And there's that method I give you, sub n characters or something like that. It helps you extract that number of characters from the phrases. So you should be using that. Okay. You don't have to use it, but you should use it. So I did notice yesterday there were a couple of questions from people, different people, talking a lot about words and stuff. You're not turning a scanner on this and getting tokens out and using the tokens to compare with each other. It is characters. The first n characters. Whatever that is, whatever n is, however long that is. Okay.
For the phrase computer class, I noticed at the beginning it marked like some documentation there. Do you want to like change that by yourself as an author, or?
So for documentation on this, for Java docs, there are a few of them I say this is already implemented, you don't have to touch anything about it. Everything else you should basically update to be the correct Java doc for your implemented method. And the top of the thing, put yourself in as author, you know, even though I'm part of it. You can add, you know, keep me in there too if you want. You know. I retain some copyright to this. Anything else?
Should capitalization matter in the search?
So my belief was that there was all lowercase. Someone pointed out that there was like one phrase that's uppercase that I didn't see. I don't know how it got in there. And just sort of ignore that. Don't worry about it. You know, just pretend they're all lowercase and assume that you're doing lowercase stuff. That also means like when I type I am, I'm always typing. You know, I'm a good punctuator, right? I'm always doing capital I, and that doesn't match anything because it's all lowercase I in the phrases. So you got to force yourself to stay lowercase on there, and you don't have to convert that to lowercase. You just say there's no match to it, right?
Just clarification. So on the Java docs, is it okay if we leave some of the stuff that you wrote and all like rewrite it all?
Yeah, but you know, I sort of deliberately didn't try to put it in the right form necessarily, like with params and stuff. So try to get the correct tags in there at least. You can steal some of the phrasing from there. But also, like, you know, if there's stuff like, hey, make sure you implement this in here, you know, cut that out, right? That's to you, not to the world. Anything else? Hopefully you saw the announcement. So we've moved some of the help hours, so there's a little more help today, tonight. So take advantage of that.
Have we learned everything that's going to be on the exam, or we still have to learn some new material?
You basically have today actually some sort of funny specifics. I have to think about Friday. Actually, Friday I'm not going to be here. It's going to be Matt, the TA, is going to guest lecture on getting back to what static really means. So we've been using static a lot, and we're going to kind of roll back around and see what it really means now in this new context. And so that's not 100% new, but some of that subtleties might be on the test, I guess. And like I said, I'll generate some listed topics for the test. All right. Let's talk about this again real quick. I think everyone sort of left a little confused. So again, this is a keyword that is a reference to the object that called the method. So let's go back to our circle class. Remember, circle class has a radius, a constructor, some getters, a setter, so on. Okay, here I am making a new instance of a circle object, right? It's small. I made it bigger, I thought, but okay. I'm calling new, and then the constructor for circle, and that makes on the heap somewhere one of these circle objects. And I am assigning its location, where it lives on the heap, to this circle reference variable. Okay? So when I talk about an object, I'm talking about really typically something like circle 1, but but really circle 1 is the reference to the object, and it's sort of the lazy shorthand. We say that circle 1 is a circle, right? It's really a reference to a circle object. Now, if I call circle 1 getRadius, circle 1 is the object that calls this method. Down here, C2 is the object that calls this method. So it's the same method with different objects calling it, right? That means in the first case with circle 1 that I'm calling getRadius, and here this refers to the same object that circle 1 refers to, because it's circle 1 that called this method. When I call getRadius with circle 2, then up here, this refers to circle 2, which is the object that called the method at that moment in execution, right? So this is not a static thing that points to the same thing all the time. It is during the course of execution of your program, when you call a method with an object, and again, that object could be 2 different objects, then this refers to the object that had just called that method. Okay? So inside the class code, this is a shorthand for who is exercising that method. Questions? Happy? Just got to say that in your head over and over. Object that called this method.
Still just don't see why you would write ambiguous code that would require this.
Right, so why do we need this? So that still is coming out a little bit. And so one example is sloppiness, right? So for example, in setRadius, I could say I want to pass in a radius, and I want to assign that, what I think is that parameter, to my instance variable. Now in this case, radius in this method all refers to this parameter. It's ignoring the instance variable that is there, because the nearest scope for radius is this set of brackets here, these curly braces. And so the first place it looks for radius is in this method, and it says, okay, I have a radius parameter, that's the one I want to use, right? So in this case, just because I chose this name to be the same as one of my instance variables, I have some problems. Now I can disambiguate, I can tell the difference between the instance variable radius and the parameter radius by putting this in front of it. Okay? Now again, that's not really the full reason why they invented this. It happens to be a use of this, but there's other more important things that we'll see as we progress about it. But this says, okay, there's an object, and I'm using the dot notation to access the instance variables of that object. In this case, the radius. And so it knows that that is now the object's radius and not the parameter radius. And I can assign the parameter radius to the instance variable by using this in front of it. Okay, so did you see the difference there? This forces it to be the instance variable, and the plain radius, if this were named something else, then this radius would also be the instance variable, because that's the only thing in scope for it. There's no other radius in this method, so it looks for instance variables. But if I have a parameter that shadows, in other words, has the same name as the instance variable, then now this one refers to this one. All right, so it's weird they let you get away with this. And it can obviously be a source of bugs and confusion, because, like I said, it's kind of weird in this case that I use this radius to refer to the instance variable, and I use radius to refer to the instance variable, and it's the same thing here. And then if I take away this and make it shadowed, then this refers to the instance variable, and this refers to the local parameter. Okay?
Can we assume that we'll learn later why we would name an instance variable and another variable the same?
Okay, so
because it doesn't make any sense right now.
Well, it does make some sense. So let me ask this question. So there's actually sort of 3 schools of thought on this, and the problem is Java doesn't enforce any of them. So it's up to yourself or your company. Typically, your company would have some guidelines about how you should do this. Okay. So one choice is every time that you use an instance variable, you should put this in front of it to make it really clear that that's an instance variable. Okay, so some people want you to do that. And so I would go through, I already have it there, and put it here. So that's one option. Another option is to use this in front of instance variables when there is shadowing going on. And some people like this because what am I passing to set radius? I'm passing a radius in there. I'm not passing my radius or a new radius or other radius. You get tired of making up variable names. And so eventually you just want to pass in a stupid radius. And so you pass in a radius and make it clear which is which by using this in front of it. So some people like that approach. So that's camp 2. So put this in front of everything, put this in front of shadowed variables, and then the final group is, no, this is all, I keep saying this, but these approaches are all nonsense. Just don't make it happen. Don't be lazy, write some parameter that's a different name, and then don't use this anywhere. All right? So, group 1. Arc cans, go away. Always this. Shadow this. Never this. And again, Java is fine with all 3 of those. Now the worst thing is to be sort of inconsistent if you're working in a group of 10 people, and some people want to do this, some people want to do this, some people do this. So again, most groups will have some sort of code guidelines that says, curly braces should be on the same line, except for, that kind of thing. They'll tell you how your format should be, and they'll pick one of these things. Who thinks always this is a good idea? All right, like 10 of you. Who likes to shadow this? All right, like 5 of you. How about never this? All right, most of you don't care, apparently. So, which is not surprising. It's not a huge deal, right? I will say that Python, instead of this, uses self, and always wants you to put self in front of it. So Python's in this camp. C++ is sort of like Java, uses this, but in a different style. I don't know. It's hard to say. I don't have a good sense what's the dominant paradigm, and I think it just sort of varies according to preference. I don't like extra words, but I sort of have the appeal of seeing this all the time and sort of immediately knowing it's an instance variable. So I have to say there's a part of me, even though I try to pretend I'm cool and don't want this in front of everything, there's a part of me that kind of wants that in front of there just to kind of point out that this is an instance variable. And so I wouldn't be, I'd be happy if someone else forced me to do that, I think, but I don't. All right, so it's all preference, but it comes up. Okay. And in fact, I think if it was used everywhere, people would be more comfortable with the idea of this because it would just be part of your normal lexicon of programming as opposed to this mysterious thing that pops up every once in a while and you're sort of, what's going on with this thing? Now, I want to make this, I notice people sometimes have trouble with one, so it's not really a subtlety of the object class approach with private things, but I think people want to invent subtleties that aren't there. So I want to talk about it a little bit. So if I have a method, Boolean am bigger than you, and I pass in a circle, other circle. So the goal of this method is to decide if the circle that called the method is bigger than the other circle. All right, so I'm looking at some, and how can we tell if we're bigger than the other circle? What can we look at? So we look at the radius. We could calculate the area, but of course that's based on radius, so there's no real point on that. So mentally you might be thinking like I'm thinking about a bigger area, but if we just compare radii, we're okay here. So most of you, I think, are pretty happy if I say double my radius equals radius. Where is this radius coming from? radius comes from the object calling this method. So let's actually call the method so we can do this. I'm going to print out the result, print out a Boolean, and so I'm going to make circle1 is the method call, is the object calling the method, and bigger than u, and I'm going to call that with C2 as the argument. So those are both circles. C1 is a circle, C2 is a circle, right? So in here, radius comes from, in this path of execution, comes from C1. It's the object that called the method, right? And C1's method is, I guess, a 10. And again, if I wanted to, if I was part of the Python-friendly camp, I could put this dot in front of that to show that it really was coming from the object that called the method. Now, if I want the other radius, how do I get it out of other? So here's other. It's a circle. What can I do to get its radius?
Use the getter.
Okay, so there's actually a couple options here. So other dot get radius. That's one option. And of course, get radius is a public method, so anyone can access that method, and that's fine. But I think, and if you want, if get radius has some safety checks in it, that might be a useful thing to use the getter. But we can also directly access radius here. Okay. Now, why can I do that? Because it's a circle object, right? And circle objects have access to all their private innards. And I'm in this from when you're inside the class code, right? So don't be scared that, like if this were something else like a square other, I probably could not access the square other's width directly because it's private, and I would have to use a getter to get to it. But in this case, because it's a circle, and I'm in a circle class, I can access its internal fields, its instance variables, directly. Right? So I've seen people get really stymied on, like on a test where I say, show me something like this. I didn't provide any getters in the class code, and they're like, I need a getter, I need a getter. You know, it's like you don't need a getter here because it's a circle object, and we're in circle class, so we can get to its instance variables.
So even though when we're technically in this code, we're not in the C1 part.
It's not like the C1 code is its own chunk of code. It's the same code. The class is the same code for all of them. And as long as you're of that type, you can get to, you know, obviously I can get to this radius here directly. We don't have any complaints about that, right? But this is just a reference to an object. Other is just a reference to a circle object. There's no real difference here.
So using the reference to the instance variables inside your class is not a bad practice. It's you just don't want people or methods or anything outside of the class to be able to access them.
Yeah, and again, the reason that we make the instance variables private and provide getters is that I'm assuming that other code is going to want to use circle. And again, at some point I might decide to change what is stored in here from a radius to a diameter or an area or something like that. And when I do that, I have to update all the code in my class here, that's for sure. But I'm in control of that, that's fine. But I cannot say whether people have tried to access those private, or those instance variables from other classes. And so I've limited the contamination, the spread of changes, basically, to just this class. So radius. So I'm going to return my radius greater than other radius. This evaluates true or false, right? And then I return that true or false depending on what it turns into. This is a good place maybe to talk about, I see, again, I think I already mentioned this once, but if my radius greater than other radius, return true. Oops. colon, else, return false. This is a very common form I see people writing. So this basically says, if true, return true. If false, return false. That's how you can read that statement, right? So why not just return the thing that's either true or false, rather than kind of saying if it's true, return true, if false, return false. So this is sort of the concise pro-style way of doing that kind of thing. This is the more beginner way of saying the exact same thing. Okay? What is bad about this? Why not? I mean, it kind of makes it a little more clear in some ways, right? Like, why not just go ahead and do that, make it all easy to read, instead of this sort of mysterious return this greater than this kind of thing.
That's efficient.
Well, I'm sure the compiler actually turns that into something pretty much the same thing. Any other guesses? Has anyone run into this? Or yeah?
I feel like it's bad to have two return statements.
Lots of returns are kind of nice, actually. It says we're done here. No problem, you know. Yeah, the worst form of this then is to say like Boolean result, and here say result equals true, and then result equals false, and then we return results. That's another more complicated form of this that we see. It's not like that much worse, but okay. So the reason I don't like this form is because half the time you're doing these conditions are like the only hard part. Well, not the only hard. They're one of the hard parts about programming. Getting these conditions to be correct, right? Like, and I'm sort of like, well, actually, maybe I should have meant that to be like that way. I do it wrong the first time or something. And so all of a sudden you start seeing people do if this. Well, let's like make it opposite because it didn't work out or something. And something's still wrong, so then you make that false, and you make that one true. And pretty soon, you just layer, instead of going and kind of fixing the condition to be really what you meant to say, you start layering changes in different spots, and it makes it really hard to track what's going on here, right? If true, return false, and if false, return true. Like all of a sudden, man, good luck kind of fixing that up. So the tendency here is to make what looks like a pretty normal statement be a lot worse, and sometimes you do that by attacking the wrong spot rather than, again, sort of finding the root cause and fixing it. And if you just return this thing, you're basically forced to just fix this Boolean expression to be what you mean it to be, and not like play around the fringes here, poking at things and hoping it works, right? So it just means that there's fewer places you can make mistakes. And it's not, eventually you're going to end up with something like that or something like that, right? You've forgotten something, and then you're in real trouble. Okay, questions about that? I mean, this is a style points kind of thing, right? So in the Olympics, you don't only get like one score for this kind of construction, and here you get the big error, or you get the 10 points or something like that, right? So anyway, just stay concise where you can. Don't be overly obtuse or abstruse with your terseness. You can make things be unreadable as well, but try to stick to saying what you mean and not layering things in between there. All right, but the real point here is that we can access other objects than the object they call the method if it's the same class, can access the internals of that class. And that's not a bad thing necessarily. Now again, like maybe there's some stuff in your setters and getters to make sure things don't go negative and things, and then it's good to use the setters and getters, but you don't have to. Okay. Now, Java is a rich ecosystem of objects, and there are certain expectations they have to make these play together nicely. And I want to show you two things here that are sort of expected to be in classes to help them behave well in larger projects. And some of this is going to be a little bit like the wrong time to talk about it, sort of like this, like you're not going to quite see exactly what's going on, but we'll I want to at least show you these things here. Okay, so first of all, when I print out circle 1, is that the only place I print? Yes, so I print out circle 1. It prints out this thing here. Package name, a class name, and then some reference material. If I print out David, it prints out David. What is this thing here? It's a string. And what kind of thing is a string?
An array of chars.
It's an object, actually, right? So a string is an object. And for some reason, when I printed out my circle object, I got this reference string. And when I printed out a string object, it printed out what was stored in it, the David, right? And so we might want to do something similar for circle, where we print out kind of what value circle is holding, so we can actually inspect the circle, rather than just this mysterious reference thing. So there's a standard way in Java to tell classes how to output themselves. And you did this a little bit in the lab, right? I just want to reiterate this. So there's the toString method that returns a string. And the string is what gets printed when you try to print an object. Now I could do something like, so I'm saying what type I am. I'm a circle, and it has a radius equal to radius. And where does that radius come from? So it's actually, so it's a little bit weird, right? So let's, let me get rid of all the print this up here that was littering this up a little bit. And, okay, so here I print circle 1. That doesn't look like I'm calling a method on circle 1, right? But somehow print circle 1 gets transformed into print circle 1 dot toString. So this is really what happens in a print. It says, do you have a toString method? And if you do, let's use that to figure out how to display ourselves. Okay, so there's some sort of hidden stuff Java's doing here to turn a printing of an object into an actual call of this method that provides a string for us. So if I now, let's see, I print out circle 1, and maybe I implemented it. Okay, so now when I print out circle 1, it prints out circle radius 10. And again, this is sort of nice if you're debugging or something, right? And obviously the debugger can help you look at those instance variables and fields. But again, sometimes I find it more appropriate to print out those values. And now instead of a bunch of references, I can actually see the values that are stored inside here. And that helps me understand what's going on with my code. So this toString thing is pretty nice. Now, there's one other subtlety. If you're making a toString, the recommendation is that you actually ask the object what its class is by calling getClass on this, and then the class can return a string with the name of the string, the name of the class, like circle here, and then if I run this, it says, it says the package.class name, radius, blah, blah, blah. And the reason for this is a little bit subtle, but at the first hit at why we might do this, let's say I want to change the name of circle to something else, my circle or something like that. And this starts printing out, just keep printing out circle. Could be a little confusing. So in this case, I don't have to update this toString to match the name of the class. It sort of gets it automatically for you. And there's a rule in, or not there's an idea in computer science that you should only represent information once. So if I had written out circle here and written out circle here, then that's two different places, and I have to keep those synchronized. Whereas if I declare this to be type circle and just access the name of the circle and print it out, there's fewer points that have to be updated to keep things consistent. So it's always a sort of good practice to, where you can, extract information rather than replicate information. And this is a very sort of unimportant use of that idea, but you can imagine it can help you in the long run, keeping things under control. All right, so the toString is like a super easy method to implement. There's no real rules about what you should say as part of it, but in general, if you spit out the different instance variables that you're holding, so you can look at the state of the object, the contents of the object, that's a pretty good thing to try to do. But yeah, surprisingly, there's no, Java's got a lot of rules, and so I'm surprised they don't say, must have the package name, dot, class name, colon, and then indented 4 spaces, list the instance variables with their values with an equal sign between them, and they're going to use that for some other fancy thing. Okay, now since we're talking about sort of common methods that are implemented in classes that help your classes, your objects get along in larger systems, I want to talk about one more that is, to be honest, a little bit more complicated. So let's look about equality again one more time. All right. So we're trying to see if two things are equal. We know with primitives we use equal equals, and that compares the values of the primitives. With objects, references to objects, equal equals checks to see if it's the same object, has the same, what we call the same identity, and dot equals checks to see if objects have the same values stored inside them. Okay. And again, we have a person with a name and a state, city and a state and an age or something. If I make a new person, it has some default values in it, then Joe references that object. If I make an assignment of Joe to David, then David is also referencing that same object. Again, they're not independent objects, right? If I try to change the name through David, it also changes it for Joe because they're both referencing the same object here. But then if I make a new person for Bill, then Bill points to a different object on the heap and is a different identity. It's a separate reference, a separate location. Now, in this case, David is equal to Joe, if I test that, because they're both referencing the same object. And again, equal equals is just testing to see if that reference memory location is the same spot. If I ask if Joe is the same as Bill, they're not equals. The equal equals is false because they're referencing different objects. Okay, their identity is different. But in this case, David is also equals to Joe because the instance variables are the same. And Joe equals Bill because the name is the same, the city is the same, the state is the same, and the age is the same. Okay, so equals can tell you if they basically are containing the same values. Equal equals tells you if it's this exact same object on the heap. So keep that distinction in mind. I still saw a lot of problems with the last assignment with people doing equal equals on strings, and it wasn't finding anything basically for the word reviews, and that was the problem there. Now the problem is, even though it seems pretty simple to say, are these values the same? Java doesn't know how to do that automatically. We have to tell it how to do that. Okay, so we need to write an equals method that satisfies all these properties, and basically the properties are just that it acts like equals should. In other words, something is equal to itself. If A is equal to B, then B is equal to A. If A is equal to B and B equal to C, then A is equal to C. In other words, transitive across all of them. A equals null is false, and if you keep doing it over and over again, it stays the same answer. So those are the kind of rules you have to match to implement equals correctly. And maybe I'll just show it, because the code itself is a little bit crazy. Okay, so equals always looks like this. The public Boolean, because it returns true or false, called equals. Here's our first mystery. The parameter is something called object, and it takes in an ob. Object is something we'll learn about pretty shortly, but essentially in Java, every class we make is automatically an object. It has object properties. So even though we call it circle, it's also an object, okay? And so we can pass a circle in here, we can pass a square in here, we can pass whatever class we make in there, except all those. Because you can test equality between different types of objects. All right? So object is just like a generic kind of thing. First, we want to see if we are identical to ourselves. In other words, if the object calling equals and the parameter that we pass to equals has the same identity, then obviously they're the same values because they're the same objects. And so we're going to kind of cut to the chase here and say if this is equal to obj, in other words, they're both referencing the same object on the heap, then we know that their values are the same, so we can return true in this case. Okay, so back to this picture. If I was doing this case, David equals Joe, then this would be equal to Joe, and I could say that they're the same value. Okay, so this is kind of a shortcut. We don't need to compare the iterates at this point because it's the same object we're looking at. It's kind of weird to compare it with yourself, right? But we can have different variables referencing that same object, and so they look like they might be different. You can't tell until we test what their references are. Next, we want to find out if it's null. So if it's equal to null, then we're returning false. We also want to return false if they're different classes. So we can that get class we can use and say, hey, if one's a circle and one's a square, they can't be equal. So return false in that case. Okay, so we have sort of complicated if it's null, or if this is different class than the other object, then say it's false. This is part we can't really explain yet. We will know soon. But essentially, obj was an object. At this point, we know it's a circle because it survived this test. It said it is a circle type. So let's cast it to be a circle type and make sure we think we can treat it like a circle. Okay, so remember, we've been casting stuff to be double or casting them to be int. In this case, we're casting this thing that we're pretty sure is a circle, but it's only labeled as an object to actually be a circle. And we'll see how that works pretty soon. Finally, I can compare the instance variables. And I'm going to say if the radius is equal to the other radius, the circle, which is really object, then they're the same. They have the same values. If you had multiple instance variables, you would have a whole bunch of those ANDed together. If this is equal to this, and the other one is equal to this one, and this is equal to this one, then they're the same. Okay. So sometimes you see this code, and it really just has this, it takes in a circle here and returns whether these two are equal. And it's not the worst thing in the world. It's just not as bulletproof. This is like the standard template for how you do this. And we won't be implementing this for a while, so don't worry too much. But when you do implement it, there's a specific style you should be following to make it all work out. And let me say one more thing before the question. There's another thing called the hash code, which we have no idea how that thing works yet. And if you change equals, you're really supposed to change hash code as well. And it helps it get organized in more complicated data structures that we'll be doing. So you had a question?
On that equals one, that first, the two if statements, that's pretty much copy paste for any object class because everything's...
Yeah, this is really a template. Like I said, you don't even have to understand the details that well. You just have to kind of get through down here and then just compare the instance variables. All right, so well, I won't see you too soon, but good luck on your time.